myself as well. Hello. I'm really impressed to see so many people in the Gradle talk. Yeah, I mean, Gradle is cool, but it's not a hot topic, I would say, but it is cool. So, yeah, my name is Andrey, and I'm a developer. Some people would call me a DevOps guy because I do a lot of automation and, yeah, all these kind of tools. Provisioning, clouds, Docker. Yeah, but that's interesting, but not about this. This talk is not about that. I'm sometimes doing trainings. I'm sometimes speaking at different conferences, including this one. I'm bringing myself as well. And I'm also organizing a community here in Riga called LADcraft, software cross-functional community. We have monthly meetings. And I'm also organizing a conference that is happening in December. And also, I'm obviously helping the Riga Dev Days a bit. Probably you've seen the dashboards, which work most of the time. Yeah, that's my baby. And if you guys have been on the talks, please vote for them using the app. There's an iOS app and Android app. And you'll just make speakers happy, especially if you vote with the 5 stars, obviously. So, yeah, but let's talk about this talk. What this talk is about. And this talk was partially inspired by this tweet. Yeah, that's JavaScript book, and there's another book from O'Reilly. They like different books about different topics, and it says JavaScript the good parts. Do you see the size difference? Yeah, and I guess I can also kind of write similar books for Gradle and Gradle the good parts, because I use it for like 10 years, almost 10 years now. Still, I love it. Still, there's a lot of things I love about Gradle, and still, there's many things I prefer in Gradle than any other tool for building stuff. Just a quick question. I guess most of you are actually using Gradle, right? Can you raise the hand? Is anyone here who is not using Gradle? Okay. Yeah. That's good. I guess most of you are on the same page, so we can easily use the terms and everything. So my path to using different build tools, my path to Gradle started through monoliths. Well, most of our enterprise applications that I have been working back in the days are monoliths, and probably the ones that you work with are also monoliths. So nothing like microservice existed at that point. Yeah, and a bit of SOA. Now people call it microservices, but yeah, it's kind of the old thing, but not that united as it was at that day. And actually quite huge monoliths. Yeah, that's actually coming from a real build. It's like 200 components, a single project. And yeah, it's not a success. It's taking too long. Of course, splitting that out into smaller components would definitely help. So things that I worked with back in the days, maybe like 10, 15 years ago, were quite big, like more than 300 lines of code, 300,000 lines of code, up to 2 million lines of code, million lines of code, and yeah, the supporting code that was needed to support all that hydra of interconnected components needed some code as well. So it's more than 2,000 lines of code just to support the code base. So build code, supporting scripts, deployment scripts, whatnot. And we have to connect dozens of components to do that. So before 2005, roughly, I was actually using Maven 2. And I was even writing Maven plugins. And at that point, it was far from a pleasant experience. And I was advocating Maven at that point. I was like, oh, yeah, Maven, use Maven. Maven is cool. And before that was before 2008. After 2008, I joined another monolithic application development project, and I had to select the tool. I searched something else, and we decided to use Gradle. So since 2008, I'm kind of a fan of Gradle. I like it a lot, and I started to bash Maven a bit after that, but not. But till 2016, I was kind of bashing Maven slightly, and was always, yeah, why do you still use Maven? Now I'm kind of a peacemaker. I'm not really bashing Maven that much anymore because I think it's okay. For certain types of tasks, it's definitely okay, and it's very good for Java stuff. So I'm trying to make peace with that. So, and obviously the build tool that you usually use, that's what we used also for many different projects, that it's not only for compiling and running the tasks and creating a jar, even though Maven does those things quite well. But also with a huge enterprise setup, what we had is that we had to, configure the publishing of artifacts in different artifact repositories, sign the artifacts using the proper signature, run integration tests, run different types of tests, performance tests, acceptance tests, whatnot, manage the databases. All the database changes were coming through source control, and we had to somehow manage that. And ideally, of course, you had to manage that through the build tool. And also, because it was a kind of enterprise SOA setup, it has produced a lot of non-standard artifacts, not jars, not vars, not ears, but a lot of things that are kind of more or less common for many projects. So configuration data and secrets were also part of the source code. Different things like LDAP, low role trees, all the user permissions management, all these things. So most of that actually is generatable from original source code. And code generation as part of your build process is actually sometimes quite hard to implement if you use tools like Maven, for example. And a lot of things. Monitoring dashboards, even Puppet manifests were part of that build lifecycle that we implemented with the build code with Gradle. And that appeared to be very handy. Still, even now, even like today, well, Gradle is great, has some issues, but it's great. And Maven is still there, is also great for certain types of tasks. And the fight between Maven and Gradle, and maybe some other tools like SBT, is visible. People are still talking about that. They're still sharing tweets saying this one is better, this one's better. Yeah, the fight is going on even now. There's a lot of tweets in the last few months that fuel that fight. Yeah, for example, this tweet is coming from Gradle co-committer, and he's kind of saying Gradle is building Gradle, huge project with Gradle like taking 5 seconds. Building the same project with Maven takes 500 seconds, or 400 seconds, sorry. And it sounds awesome, right? But when you read the conversation after that, you realize that actually it takes 5 seconds when Gradle is kind of warmed up. It's using the daemon, it's using the cache, it's kind of using incremental features that it has, which Maven doesn't, well, have to some extent, but not fully. So it's not really cold run comparison. So in that sense, not very fair. At the same time, there are many people who are still loving Maven too much, and they have a point. I know they have a point because, for example, recently I have the project that I started like long ago, 7 years ago, when we used a lot of Gradle at that point. I had a chance to return to that project to help them out with upgrades and all the stuff, and I've seen that Gradle codebase that we created. Oh man, it's a lot of custom, unsupported spaghetti that is very hard to read. Nowadays, I would definitely write it differently because I know Gradle much better now. But I can understand people who are better with Maven, because Maven is, even though it's verbose, it's XML, whatever. But it provides a set of common paradigms that are easy to recognize and easy to remember and easy to adopt to. Gradle is customizable, and that's a good thing. But you can easily fall back to a situation where Gradle is very unmaintainable code. And so I can definitely feel that some people are unhappy about that. Sorry. And this is also true. Smaller projects is faster to build with Maven. Gradle, if it's a cold start, will take longer time because of the configuration phase, because of the not initialized cache. And Maven is definitely faster in that setup. If you have to continue to restart the build and do it again and again in a repetitive fashion, Gradle will be faster because it has some smart functionality built in and is actually getting even faster with every release. Yeah, also there's like talks about Maven versus Gradle. They compared the features, and that's interesting. But yeah, you know, there's another actually quite famous guy. He's author of BDD, and he is keynote speaker in many conferences. He just, yeah, obviously he hates Maven, and he just likes Gradle. And one guy like him is a guy like Danoff is saying things like that. Then obviously people will follow him and hate Maven for maybe for no reason. Still, people are there with different opinions. With Maven is okay because it's not Gradle. This is actually a valid point about Maven and Gradle comparison. Is that within 10 years of existence, almost 10 years, we have 154 releases. Stable, good, tested releases. At the same time, Maven, within the 15 years of development, has three times less number of releases. Which obviously shows that Maven is not developing that fast. Gradle is developing much faster and introducing more and more features. At the same time, there is a set of features that are existing in Maven for a long time, and they were either recently introduced in Gradle or not yet introduced in Gradle. So, for example, a test parallelization, when we can run tests in parallel, it works in Gradle already, and it was introduced like version 1 something, but still Maven is more advanced in this area. Gradle has some other good things. So some things are different, some things are working better here, better there. So now, when I actually see when people like having religious fight about what is better, Gradle or Maven, actually, yeah, I like this guy. I haven't met him in person, but if I will meet him in person, I would actually shake his hand because I have the same opinion. I'm comfortable with both of them. I know the limitations of Gradle. I know limitations of Maven, and Maven is good enough. It's a good enough standard for integrating with the tools, for integrating with simple Java libraries, building more or less simple projects, and it's faster. At the same time, Gradle can be used in enterprise setup when you have to do a lot of customization, a lot of code generation. Gradle is much simpler in that setup. So yeah, let's stop fighting, obviously, because otherwise, Bug will take over. Do you know what is Bug? Yeah, Bug is a tool from Facebook. It's built specifically for building Android applications, and it tries to leverage the small package design and building everything in parallel. Something that Maven and Gradle is already capable of, but maybe not as fast as Bug. But Bug is very, focusing on specific tasks. It's only focusing on Android at the point. Maybe it's going to be extended into using other stuff later on. So in that sense, I would say that Maven probably should stay in the format it is now, just have more standardization going on, and Gradle probably should also come to more standardization than to get more features, because they have actually they have really great team that is working on the core, and they really make good at making good new releases every 2-3 months, which is really great. Okay, now let's go. Well, let's try to go through the features that actually I like about Gradle. Some of them are maybe very old. Some of them are quite new. But most of them are the ones that I actually use quite often. That's what I try to use in my builds when I configure the builds. So the good parts. I'll actually probably also mention some not so good parts, but let's see. Obviously, the good part of Gradle is that it's actually following the same conventions as Maven. And Maven was really a good thing for Java ecosystem by introducing these things like SRC main Java, SRC main Groovy, and SRC test, all this stuff, all the normal project structure and the structure for repository. That's something that you would never take from Maven. It's them who created that, the team behind Maven. And Gradle was smart enough to actually reuse that structure and make it recognizable. Another thing that some people probably consider a bad thing, and sometimes it actually turns to be a bad thing, because when you overuse it or you don't understand how the DSL works, you may end up with very unmaintainable code. But if you stick to the basics, if you stick to the things that a Gradle DSL already defines, then actually it's quite declarative. It's quite declarative, and it's definitely better than POM XML. Another good thing, obviously, is the API. I really like that polymorphic domain object container. Cool. Oh, I'm kidding. Of course, the best thing is project and rules and scripts and tasks. All the common concepts that you will see in the build. You have an API object for that, and you have JavaDoc for that, and you can actually access those objects inside the Gradle code, which is great. Yeah, and the most common things from API is project, task, dependency, artifacts, and source set. That it's worth knowing. If you are really into Gradle, it's worth knowing what these objects provide. And JavaDoc is there. I mean, it's public documentation. Another good thing, obviously, is that if you guys use Maven, I guess most of you had some sort of relation to Maven, defining dependencies is quite hard because it takes at least 4 lines of XML, which is 2 verbose for 2017. So Gradle provides this notation of having 1 line defining the dependency location. And I guess you guys all know that. It's group, name, version. Also, it could be classifier, so you have some code compiled for different JDK versions, like JDK 4, JDK 7. They could be there, but it's optional. And also could be packaging. So you can actually, using Gradle dependency notation, you can not only get jars, you can also get ER files, var files, zips, and whatnot. That's actually what makes it quite powerful, because you can actually package and use normal Gradle abstractions to get artifacts of non-standard type. So for example, here, we're just getting a set of Puppet manifests. We just downloaded it from the same Nexus or Artifactory, and then we do something with them in our build, which is quite powerful technique, actually. Another thing that actually exists quite a lot inside Gradle DSL is the copy method. Well, actually, it's a set of copy methods and set of copy abstractions that Gradle introduced in very early versions of Gradle DSL, which allows us copy files. And that's, in most of the cases, that's what actually build tool is doing. It's copying files, processing them, doing some filtering on top of them, and copy language or copy DSL is quite powerful. So in here we say we have to copy it somewhere. We're excluding some stuff, we're copying it from somewhere, and we can have more than one from source. And we can then filter it on the from level, and we can also do some replacements. Another thing we can do, actually, something that is built into Gradle, and something that for this thing you actually need a plugin for Maven, but in Gradle you can do it in one task like that. You can copy not only files or directories. You can actually say that I want to copy the whole configuration of my project. And configuration in Gradle is a list of the libraries that we depend upon. So if we want to copy the test runtime libraries, we can do it in one way, in this simple way. And this is a very powerful thing. In this way, we can create fed jars. We can create distributions of our code with the libraries and just with a simple copy task. Not many people actually are aware that copy task provides that. Another thing that you can use together with the copy task and with the copy method as well, because actually it's the same functionality going behind the scenes, is that you can use the zip tree. Zip tree means that this from source actually getting a list of elements inside the zip file. And then we can do anything with that. So even though the task is called copy, we actually do unzipping. And then we can do zip with the zip task. So again, something that is could be very powerful when you have to repackage the artifacts and add some more stuff into them, or when you have to create new artifacts based on a set of other artifacts. Could be quite powerful, and that's what I use quite often, actually. If you need to do some logic for each of the artifacts that you actually process inside the zip tree, you can override that, and that's one of the best things of Gradle. You can override pretty much anything. And in most of the cases, it's not a lot of code. It's just, it's a bigger challenge to actually find in the documentation where it describes that thing. But Google can help us. But in general, a lot of things are possible. And this DSL is getting more reach with every version of Gradle. So it's worth following up on that. Yeah, just a few documentation links. Another thing that Gradle has is the wrapper. How many of you guys use the wrapper actually? Most of you. Okay. And that's one of the things that actually also was implemented in Maven eventually. Not by Maven guys, but still there's a Maven wrapper as well. And basically, yeah, this is just a few files situated in your project source code, and you have to commit them. You have to commit them because this is the way to stick the Gradle version to the project. So and this is why actually it is easy for Gradle team to go and develop new versions, because anyone on the planet who is using Gradle can actually stick to the version that they're currently using, and they will be safe to upgrades because the version number will be written inside the Gradle wrapper properties, and this is basically this URL, which basically says, please download. If there is no Gradle distribution in your machine, it will go to the URL, download it, unzip it, and then we'll run Gradle from that distribution. So now people don't need to run don't need to install Gradle. They just run Gradle W, which is Gradle wrapper, and they can also run the exact version that this project was designed for. So this is a good thing for your project to have Gradle wrapper, and this is a good thing for Gradle team because they are not afraid of deprecating features, because if everybody is using Gradle wrapper, then they're basically safe. Sorry. If you are a Mac user or Linux user, you can also take advantage of GDUP. GDUP is a simple utility which basically tries to locate a Gradle wrapper script inside the directory structure, and this works very good if you have multi-project builds. We have a lot of sub-projects, and you have only one Gradle wrapper which is inside the root of the project. So usually it's a common mistake when you go outside of the when you go inside a sub-project and you try to run Gradle V, it's not there because it's on the root. And GDUP or GW on the command line will actually try to find the closest Gradle wrapper script inside the tree and run that. And also it's kind of shorter to run. There's like numbers here. So I would like to write something like that also for Windows at some point. But so far, if you're on Linux and Mac systems, then you're could be more efficient with running Gradle scripts. Yeah, and there's Maven wrapper, which was created in the same fashion as Gradle wrapper. There's also actually Ant wrapper if you like that. Another good feature that was introduced in version 2. something, if I remember correctly, 2.8, around that, is the continuous build. This is a magic flag, -T. When you run the task, let's say build or compile, it will run in a console mode without exiting. So, and will continuously monitor the inputs of the task, and if something has changed, then it will recompile that or run the task for those specific things. Actually, these slides were made also with Gradle. Okay, I'll kill this thing. And I have this Gradle -T build running here inside a separate console window. And if I go into my slides, let's say continuous build. This is Markdown. So slides are built from Markdown. And if I search for continuous build, and I will add something more here, and I will save it now. Gradle will actually detect it, change detected. If you see that, change detected, executing the build. And if I refresh the task now, I will see that it actually changed. And the same is possible not only, of course, not for Markdown files, but also for Java files, for any kind of resources. Actually, Spring Boot and some other libraries like Redpack supports this continuous mode, where you can just, run your build inside the separate window and then just work with your code. And it will automatically rebuild the parts that were changed. And the reason it's possible is because Gradle, since I think version 1.5, we started introducing a special API for managing task inputs and task outputs, which basically, this is the reason Gradle is capable of detecting what has changed, what has not changed. And if you're defining your custom tasks, you can actually also do that. And this was very handy if you're doing a lot of code generation inside Gradle scripts. Then you can define what is the input, what is the output, and Gradle will be smart enough to detect that as well. And that's what's happening in my build for Markdown slides. So you can define that your task has some src directory as input or configuration file as input, and also the output, like let's say some sort of package file. And this is built into the API. You just have to declare that inside your tasks. Also, if it's very complex, if it's like depending on some kind of API call or some strange status which is not a file, you can actually do that with the closure, with up-to-date when closure, and define the custom code that will detect that this task is up-to-date. And if it's not up-to-date, Gradle will run it. Quite handy, actually, and I use it quite often and when I need custom code generation. In Gradle version 3.4, and 3.5, obviously, they actually made a special incremental Java compiler, which is even smarter than just using task inputs and outputs. It actually can do cross-project dependency detection. And if you have an API project and another project using the API, if you change the API, let's say, or only part of that API, it will rebuild only the files that depend on that specific API class. Not everything, but only that part. And that's actually pretty awesome because you can actually do quite quick rebuilds. So Gradle is optimized for continuous rebuild of things with using the information that it's known based on the tasks input, tasks output. So it's going further with that. And obviously, Gradle is using cache for that. So these cache directories, they exist for a long time, and it's just Gradle is extending the cache information with pretty much every release. And you probably notice that in every Gradle project you have .gradle directory, which actually contains information about these tasks inputs and task outputs in binary form. So if you delete that directory, then this information will be lost. So tasks will not be up to date. But if you keep it, Gradle will actually consult that directory first before verifying that task is not up to date, and only in that case it will execute the task. Yeah, also there's a lot of stuff in .gradle, some compiled scripts, compiled downloaded dependencies. So if the script has changed, actually it will mark the task as not up to date and will run it. So it's tries to be quite smart, and actually it is quite smart. It works most of the cases. Okay. Another thing that, yeah, Gradle obviously, well, Gradle is trying to be quite Maven friendly, so they try to understand all the Maven conventions, all the Maven dependency formats, and also you can actually use Maven local repository. That's what actually this is something that comes as a surprise for heavy Maven users, that you can't reuse Maven local repository from the very beginning. You have to define that you want to use it, because otherwise you actually only use Gradle cache. So, and you can do that. Another thing, daemon. Daemon exists since version 1. something, I don't remember exact version. And it was initially made as an experimental feature. Now it's always enabled, and it's another way, to make the continuous repeated builds faster. Because for the first build, it will always start the daemon process, and we'll put the compiled code inside that daemon process, and we'll use that daemon later on the next run. The good thing about daemon actually can be disabled. Unfortunately, I have some issues with daemon sometimes. Sometimes it's not detecting itself, but in most of the cases, actually it works fine. And if you want to see how many daemons are running inside your current machine, you can use Gradle v ---- status, and you will see all the daemons that are working. And it's usually one daemon per Gradle version and Java version combination. Yeah, that's what I once seen on my machine. One busy daemon and 70 stopped ones. Completely demonized machine, yeah. Another thing, because Gradle is trying to fight and to address the performance of build tool, and they do a lot of these tricks with the cache, with the task input outputs, and recently, like I think it was 3.1 version or 3.0 version, they introduced this plugin called build scan. It's fun to use actually, because especially 5 different developers are using the same build scan to see how the build actually is running on different machines, and you can actually compare the hardware. The problem with that plugin, actually, it sends your build data to the public server. It stores there I think for like a day or something, but still, yeah, quite a bit suspicious, but quite interesting just to play with. In order to run your build command, you just have to add the scan property to the command line, and then it will send build performance data to the Gradle.com, the public information, and you will see like the timings, the information about dependency resolution, configuration management. You will see quite detailed information where this build is spending time on, and this is quite good for comparison. Between different developers, between your machine and CI machine. But I don't use it like on a regular basis, but at least in the beginning when trying to optimize the Gradle performance build. Then when we use this just to get some input. Another thing that was introduced quite recently, and something that actually allows to split monoliths into more components, independent components, is called composite builds. Basically, you can have inside your build, you can have a library you depend upon, and that library can come from another source. And if you want to provide that, and if you have a Gradle build for that library, you can provide Gradle information with that, and then it will, instead of fetching the library from the cache or from the remote repository, it will actually go to the actual Gradle project and will run this whole setup as a single project, even though they're two separate projects. So it's quite good if you have several components and you want to develop something that is cross-component change. You can actually use composite builds to combine to work on them simultaneously. And when you're done, you just go back to developing them separately. So it's quite convenient thing, and that's what is very handy when you have a monolithic build and you want to split it into more builds, independent builds. Also, Gradle has a lot of built-in tasks now, especially in 3.5 version. It has a lot of things. One of them is init, which just basically allows you to initialize the Gradle project from scratch, zero thing. Also, if you want to add wrapper to your project, and actually init does that as well. But if you didn't run init or have existing project, you can use wrapper task to actually add wrapper to your Gradle project, and you can specify the version. And it's the best thing is to specify the latest one. In this case, it's 3.5. Also, another thing that I found quite often, people who are not really familiar with Gradle, they struggle with the task names. They don't really know which tasks to run. And of course, clean build is pretty much always available, but if it's a lot of customizations done, then they don't know what to take information from. And that's what I'm usually saying them. Just run Gradle tasks. You will get all information about all tasks available in this particular project. Also, you can get the tree of dependencies of all configurations of your project using this simple task. This one, Gradle status, where it is seen. It shows the status of all the daemons, all the 71 daemon on your machine. Gradle GUI, I don't think it's updated very often, but also could be a good way to give you a graphical overview of what kind of things you have in your Gradle build. So it's kind of similar to Gradle tasks command, but yeah, graphical. And you can actually execute things from here just by clicking on them. This is very handy sometimes for people who are not writing the builds but using the builds, so like system administrators or operators who need to re-execute some tasks from time to time, like deployments, publications, and all this stuff. Yeah, just use the GUI. Okay, how much time? One thing that Maven guys are actually complaining a lot about is that Maven is much better in IDE, and it is. Unfortunately, it is. So IDE support for Gradle is okay, but it's not ideal. Usually people who prefer Maven, they expect their IDE to actually work with Maven out of the box. For example, NetBeans, you don't need to actually define any NetBeans project files. You just import the Maven project and it works with the POM, original POM, which is great, and it's valid expectation. At the same time, with Gradle, you can kind of do the same thing, especially with IntelliJ IDEA. It works okay. It actually works more or less good. But it wasn't the case maybe a year or two ago. Now it's definitely more stable, but yeah, a lot of crashes. I've seen a lot of crashes of IDEA back in the days. And the problem here is basically the language, because POM is XML. You know, it's easy to write an XML editor for anything. I mean, XML editor is easy because we know the schema, we know what values to expect. To write editor for Gradle code, for scripting code, for Groovy code, which is very highly dynamic and it can be highly customized, is really hard. I would say it's probably even impossible. That's why none of the IDEs actually support it very well. And basically, for example, in IntelliJ IDEA, I usually just switch off the Gradle support for syntax highlighting and editing because, yeah, it's just useless in most of the cases. But the thing is, also I kind of get a bit not really caring about that problem. I know it's probably, you know, it's a bit, I'm adapting to the tool, so I actually adapting to the way I use Gradle. And maybe I have to expect something better from IDEs, but honestly, I don't care that much anymore because I just rely on these plugins and I generate the files from the actual project, and in most of the cases they just work. So and this kind of thing allows me to to not go into the fight which IDE is better. Is it IntelliJ IDEA or Eclipse, and then people starting discussing which one is better? I don't care. I just just go generate the project. Of course, the life cycle is a bit different. You don't import them and then IDE updates it for you automatically. You have to regenerate the projects when there are updates. It's a bit annoying, but it's tolerable thing. So this is the default setup for me at this point. And I just have to run clean IDEA or clean Eclipse, and then whatever tool I use, I have the project files. Yeah, there's just IDEA has this issue with importing Gradle project, and I think they fixed it in the latest version. I think they added auto import functionality recently. Not always. It doesn't always work, unfortunately. So you have these extra steps when you're importing stuff from generated projects into IDEA, which is tolerable. Maybe not super okay, but tolerable. Yeah, and Gradle also has Eclipse plugin, which is called BuildShip, which has a similar experience for IntelliJ IDEA. Okay. Another thing I wanted to mention is the way I structure the build. And the best thing that, well, not the best, one of the good things that Gradle provides is Gradle properties. The thing is that you can commit Gradle properties into version control with some basic default values to make your project runnable, and anything that is inside Gradle properties will be visible as a property inside dynamic code. But the good thing is that these properties are totally overridable. You can override them by placing a Gradle properties file inside the user home directory. So it will be something that is completely custom for you. you can override that by providing a command line parameter with -p and then the property value, and then this will override actually the one in the user home. So it's very like CI environment friendly. And yeah, if you prefer using environment variables, which could be the case, again, you can do that as well. And this will override also the property value and then the other one. And yeah, this makes it really easy, to write build files, build tasks that work with real stuff. At the same time, they isolate the secrets. They don't inject the secrets into the build code. You can customize your settings depending on what kind of things you have on your own computer, what kind of things you have in the CI server. It's very handy, and it's very like DevOps oriented, I would say. Another great thing that Gradle provides, and this is my most popular answer on Stack Overflow. It almost got me like 1,000 points just saying that Gradle has that feature. And in Gradle you can basically extract most of the functionality into a separate file and make the build code much more structured in that sense. And that's what I use quite heavily. At the moment I have several common snippets for different parts of project lifecycle that I reuse in different clients and I reuse in different projects. And I just usually I put them inside the Gradle folder where the wrapper is, and then I just refer them from the main build.gradle file. And that makes the master build quite small, and then just all the specific configuration for, let's say, Java dog generation and similar stuff is placed inside Java.Gradle, and is the same between different projects, more or less. Things like IDE support, things like SonarQube, things like integration tests are going into this kind of facet scripts, which I can customize and combine on different projects depending on the needs, which is quite good. Also, Gradle makes it incredibly simple to write plugins. This is enough code, actually. Just you can put it in your own build.gradle. This is the plugin. That's it. Nothing. You don't. Well, of course, you can extend the code, but make it more useful. But in order to start writing plugins, you don't need anything else than Gradle. Just write it inside your build code. When you're ready, when you have enough code, you can split it out and move it to the next level, which usually is build SRC. So if in your project you have build SRC directory, Gradle treats that as another project of your multi-project build, and it just adds all the Groovy files, all the Java files compiled in that particular project onto the class path of the build script that is actually building your application. So we can start like that easily. Then, when our plugin code grows, we can actually put it into build SRC to isolate it from the main build code, use that plugin inside our main build code, and when we are like completely ready, and when we see that this plugin probably is super useful, then we can jump and go to isolated project and deploy it to Maven repository and use it from there. And in that regard, there's also a way to test plugins. There's a special framework that exists for testing plugins, and this is actually, it's part of Gradle since version 2.8, like I think 2 years ago, around that. Basically, the only thing you have to add to your plugin project is this Gradle Test kit, which is basically just a set of jars that have some extensions for JUnit, and you just write JUnit tests in the same way you would write it for your application. So, for example, you may define your custom built file using a simple string, and then you can use Gradle Runner, which is a base class for the first entry point you use it for testing, to create a test Gradle environment through which you will test your script, which will test eventually your plugin, which you probably also have. The source code is inside the same project. So yeah, we just execute Gradle within some test environment, some test project there, which may be a temporary directory, which you created also inside JUnit. and you just run the build, you just run the runner, and you can run it with different versions, different installation directories, different distributions. So as you can imagine, you can test your plugin against different versions of Gradle and verify that actually works. And this is part of Gradle. You don't need to, this is part of Gradle now. It was not the case a couple of years ago, but now it's very easy. Gradle provides everything for that. Yeah, also you can use asserts, obviously. So the result of the build that you get here, it returns you the output of the command line, the exit status, and basically everything you see on the screen is packaged into this build result object you can do assertions on. Yeah. If you still have to develop plugins for something that is older than Gradle 2.8, you can use another framework that is called Gradle Test, which is written by Skullcronia, who is quite vocal in Gradle community. And yeah, it's just another plugin you can use to do that. And I think in some cases actually it's more handy to use this plugin because it provides a more declarative way of saying which versions of Gradle you want to test your plugin against. So this is the way to import the plugin, and this is the way to configure the plugin. So you can say that I want to test my Gradle code against these versions, and this is the part of the Gradle build that builds the plugin. And yeah, I just run the Gradle test command, and it tries to download things and test them. So it's quite handy, I think, as well. Okay. Yeah, let me now go through a set of useful plugins that I use quite often, or I find useful as well. License plugin will check what kind of licenses you have inside your dependency tree, and this is very handy in enterprise environments which care about not using JPL. Sometimes a versions plugin will actually check if your Gradle build actually has the latest versions of the libraries that are published inside Maven repository. Something similar exists in Ruby, I think. Shadow plugin is kind of a way to create fat jars out of many dependencies. So it's nowadays I would probably not use it that often, but still it's quite handy. And the funny thing with the shadow plugin is that it actually has task shadow knows, and it displays some ASCII art, which is like Easter egg inside the plugin. If you are working with installers, you can use eSpec. Also, this release plugin is the same thing as Maven has, the release plugin for Maven, and it works in a slightly different way, but very familiar to the way Maven release plugin works. And this is usually what I use on open source products, and to tag the version control repository, publish it with the new version, update the version inside the version control. So yeah, with just one command, and all those things are done. There's a lot of things working with like coverage and documentation, markdown, live reload is kind of, if you remember the trick I did with the continuous build, if I actually used also live reload, I would not need to do the refresh manually. It will actually be refreshed automatically. Within the browser, you can use live reload for that. Yeah, Nexus, PyTest. Gradle ecosystem is full of plugins. Also, this one is quite handy, especially if you have to package not the jar, but you have to package an RPM or DAB, a Debian package. Then OS package actually saved my ass a couple of times. Really? It says 11. No, it's fine. I mean, actually, I'm finished. So, yeah, and another thing that I haven't tried yet, but I was actually looking forward into, because I hope it will actually help making Gradle IDE support better, is Kotlin support. And I haven't tried it yet, as I said, but really looking forward to that. So, yeah, takeaways from this presentation. I hope you found something useful in that. So Gradle is not ideal, but obviously has some issues. But it has a lot of good things. And for me, the best things are APIs, DSL, the ecosystem of plugins, and team that's behind Gradle, and the community that's behind Gradle, which makes that even a greater tool. and that makes Gradle to constantly evolve. Also, you can find some useful links about tuning Gradle performance and some awesome Gradle tips. It's, you know, I could just compose my presentation out of that, but I was trying to use just my own experience. And yeah, that's all. I hope this happy elephant represents the happy Gradle user as well. Thank you.
Maybe you have questions?
Questions?
Anybody?
Yeah, they're all happy Gradle users, so it's...
So no questions?
Yeah, one question. Well.
Are there any specific projects where you recommend migrating from Maven to Gradle?
If you have a lot of customizations inside the build artifacts, and if you have a lot of code generation that is not standard, if you really, you know, integrate, need more integration points than just a jar, then I would definitely recommend Gradle. If your project is really very much standard, if it's just, you know, a var file, then you can actually happily survive with Maven, and probably it's okay if you use Maven for that.
So Maven, it's a good choice for microservices.
Yeah, maybe. Well, Gradle is also okay with that. I mean, Gradle is fine with that as well.
Gradle is fine for monoliths.
Monoliths, it's actually, yeah, shining in monoliths, but also Gradle is fine for microservices. No, it's not that it's bad for that. It's actually very good for that as well. And honestly, personally, I would insist on using Gradle in my teams because I know it very well. And I know the features, know the plugins, and but I see that sometimes it could lead to unpredictable, unmaintainable code base that not everybody will be able to maintain. So if the team is composed of people who are not familiar with Gradle and who are very much using Maven, then I would probably select Maven in that case. So it's not the target architecture that is the problem. Usually it's the team that should decide on the tool, and then their skills, in my opinion.
Actually, I've seen very complex Gradle projects.
Yeah, me too.
And special teams maintaining especially Gradle scripts. Yeah,
I've seen that too, also in Latvia. And well, you know, sometimes people who are creating the scripts, they don't know enough about Gradle, and they may make it overcomplicated. I've seen such examples as well. And then when just we look at the build where we factor that, then we ended up using very standard features, very declarative things in Gradle, and then it was fine. But so, yeah, it's easier to overcomplicate Gradle.
Yeah, it's very easy.
So yeah, I would really make a decision on what to use based on the projection of how the project is going to be supported, who is going to support that, what kind of skills people are going to have, and yeah, Maven probably would be a good choice if you have like people who are not really familiar with Java. Then they will actually be more happy with Maven because it's kind of standard format. And but if you start doing a lot of customizations inside Maven build, then it's definitely a sign that you have to switch to Gradle, switch to Gradle, switch to Gradle, switch to Gradle, switch to Gradle.